Hello everyone. Myself I am Saranya, working as an assistant professor in the Department of AIML in MLR Institute of Technology. Today I am going to discuss a topic of a model for network security and block cipher modes of operation. These are the two topics we are going to discuss in this video. So first topic is what is model for network security and what are those example of model for network security and what is the block cipher modes of operation and how many types of block cipher modes of operations are there. We need to going to discuss in this video. So first one is what is a model for network security. So basically we are using a security related information which has been sent for the sender and the receiver. So there is an third party intruder. So it is nothing but an information to be sent and also which scrambles the message, so that is an unreadable by the opponent. Opponent is nothing but any relation between the sender and the receiver, that is message is going to be delivered. In between of them there will be an opponent. So that based on these contents of message which can be used to verify the identity of the sender. So whatever the information is going to be sending by the receiver, there is used to verify the identifier of a sender. So there will be some example of secret information which is shared by the two principals. It is nothing but a sender and the receiver. So the unknown to be the opponent. Here there is an example of encryption key. So encryption is nothing but an having a securing key between the sender and the receiver. So it is used with the transformation to scramble the message before transmission and unscramble it on the reception purpose. Before transmission they are going to scramble the message. So here there is a trusted third party. It may be needed to achieve some of the secure transmissions. Means they need to achieve some of the secure information, whether it is related to the personal or impersonal. They are needed to achieve some of the information from the sender and the receiver. They are going to access by the third party. So, and this third party may also be responsible for disturbing the secret information to the between to the two principals. Here nothing but two principals is nothing but a sender and the receiver. Sender and the receiver, they are going to be keeping as information from any opponent. They are going to hide the information. So what is third party is doing here? The third party is maybe responsible for disturbing the both the secret information of the two principals. That is nothing but a sender and the receiver. The sender and the receiver going to whatever the information is going to keep the information secure. That information is going to take from the third party. So see some of the example in this figure. We are going to see sender and the receiver. So here sender is there and the receiver is also there. So the sender is going to send some of the securing message or secure of the information to the receiver. So in this receiver there will be an opponent and also the trusted third party. Nothing but any disturbances or any arbiter, that is called as an trusted third party. It is nothing but an hacker. So this hacker tries to gain the information from the sender. So whatever the information is going to send the information to the receiver, they are going to hack the information between of the receiving the messages. So there is a secret information while they are sending the information to the particular receiver. There will be any information channel or any through communication channels while receiving the sender to the receiving message. So this generally model, this contains of 4 basic tasks while performing a security services. First one is they are going to design any algorithm for the security related transformations, because any for the security related performances they need to design some of the algorithm. That is nothing but a model for network security. They have designed that model for network security for the security performance. So this algorithm should also be such that an opponent cannot defeat some purpose. And also second one is generate the secret information to be used with the algorithm. So the secret information must be generation form while using the model for network security algorithm. and it also contains the developed methods for the distribution and sharing of the secret information. And also they need some of the developing methods while they are going to send the information from sender to the receiver. And also to specify protocols by using these two principles, by the security algorithm and also to secret information. While before in the video we have discussed with the security services, security mechanisms, and also the OSS structure, security structure. This three also comes to in the part of an model network security. So there are 4 basic tasks. One is we need to design, and we need to generate, and we need to develop, and we need to specify some of the protocols by using the 2 principles. And also one more example we can see here. Here the opponent is nothing but using of human and software. Human is nothing but an example of hacker. Software is nothing but a virus and worms. So while we are getting information, obviously it will get from the software purposes. So software is nothing but a virus and worms. We know the differences between virus and worms. So virus is nothing but it can easily infect the file from one system to another system by using of the person, including of person. But worm is nothing but without an involvement of human interaction. That is the differences between the virus and the worm. So here there is an opponent. The opponent is going to access through access channel, while this is the gatekeeper function. What is the purpose of the gatekeeper function? Whether there is entering the unknown person or known person, they are going to check. That is the main function of the gatekeeper function. So, and also here the information system. In this information, what the information is going to be inside of the computer. So there are many computing resources, data and process, and again software, and also the internet security controls. So the main theme of the network security is to hide our personal information and keep our personal information more secureable. And also another type of unwanted access in the computer logic that exploit vulnerabilities in the system. So they can affect any application programs and also utility programs such as editors or compilers. So editors and compilers can also be using of that exploits vulnerable in the system. So by using these programs, we can present 2 more types is information access threats and also the service threats. Information access is that nothing but to modify the data. Service threats is nothing but it used to service flaw in order to inexhibit used by legitimate users, means particular users only. These are the 2 types we are seen in the programs that can be having any other 2 kinds of threats is nothing but an information access threats, and another one is service threats. And also virus and worms. We have discussed in the previous slides what is virus and what is worms, and these 2 are also example of software attacks. In the most software malware attacks, it is a main of virus and worms. And these such attacks can be introduced into the system by means that contains the unwanted logic concealed in otherwise useful software. Means it can also be included in the attacks types of into the system. The main purpose of into the system is nothing but an virus and worms. The difference between virus and worms is nothing but an human interaction, and without human interaction is known as an virus and worm. They can also be inserted into a system across a network purposes. So we are discussing about the network security. So it will come under the only acrossing a networks only. So that is the topic of model for network security. Jump into the next topic, that is nothing but a block cipher modes of operation. In this block cipher modes of operation, how many bits we are going to use and how many sized blocks we are going to use by each and each operation. We are having the 5 types of operation. Nothing but electronic codebook, cipher blockchaining, cipher feedback mode, and output feedback mode, and next one is counter mode. These are the 5 modes of the operation we are going to see in the block cipher modes. So see here, the block cipher modes of operation, it defines mainly to secure the encryption purpose and the decryption purpose. So to encrypt and decrypt a large amount of data using a block cipher. For the encryption purpose and the decryption purpose, we are going to use by These all 5 techniques, how they are performing by using the fixed size blocks. It is an encryption algorithm that processes data in fixed size blocks, for example, 128 bits rather than 1 bit at a time. So, it contains a fixed size blocks, for example, of 128 bits. So, it consists of 5 modes of operation. First one is electronic codebook. Second one is cipher block chaining. Third one is cipher feedback mode. Fourth one is output feedback mode. And fifth one is counter mode. So, coming to the first type of cipher mode is nothing but a electronic codebook. So, what is the electronic codebook? It is the main easiest method of the mode of functioning method, and it also easier to direct encryption of each block input of plain text and output of ciphertext. Means what is the main purpose of the electronic codebook? We need to have the direct encryption of each layer of the input plain text, and we need to get the output of the ciphertext. That is the main performance in the electronic codebook. So, input plain text and we need the output in the forms of the encrypted ciphertext. Plain text is nothing but an conversion of plain text into ciphertext. By ciphertext is nothing but an conversion of main original plain text, that is originating from the plain text, that is the output of main ciphertext. For example, if a message is larger than b bits in a size, so it can be broken into bunch of blocks. Bunch of blocks is nothing but, here see, process 1, process 2 and so on up to Pn process. Here P is nothing but a plain text and C is nothing but a ciphertext. For example, in this diagram, we are going to discuss only the 2 purposes. That is nothing but an encryption purpose and another one is decryption purpose. The first purpose is the encryption. Here encryption consists of plain text 2 and up to plain text n purposes. What is the main purpose of this plain text and convertence? We need the input of plain text and we are going to take off the output of ciphertext. That is divided into bunch of blocks, that is 1 to up to n minus 1. So, I have taken here some of the plain text that is going to be encrypted and it gives the output of the ciphertext. Like that, we are going to take the process of P1 to Pn process, means dividing into bunch of blocks up to the nth process. Here K is nothing but a secret key, means we are going to secure our message by using the secret key. P2 also same process running by using the secret key, that is going to be encrypt and again it gets the output of the ciphertext of second block. Again here Pn means nth block of the plain text is going to convert by using the secret key. It gives the output of ciphertext of nth block, which is nothing but an encrypted format. The same as the decryption format is also same as the plain text, means whatever we got the information original plain text, it is going to be converted with the ciphertext. Here ciphertext 1 is taken by using the same key of K, means K is nothing but a securing message or secret key. By using the decryption process, we will get the original plain text 1. So, already we have seen in the process of encryption, that is the same reverse process of the decryption process. Here C2 means second block is jumping into the conversion of secret key and it gets the output of plain text 2, means it also be decrypted. Like that, from C1 to and so on up to Cn, it is going to be decrypted by using a secret key and it gives the output of plain text. Here Cn is also converted by using the secret key and plain text is also the output. Encryption, we need to get the output of ciphertext and decryption, we need to get the output of plain text. That is the basic difference between the encryption and decryption in electronic codebook process. The next second type is cipher block chaining. In the cipher block chaining, we need to give in as input to the next encryption algorithm by using the XOR operation. By using the XOR operation, we need to give input to the next encryption algorithm with the original plain text block. Means we need not to decrypt, so we need to give the original plain text block. Means not at all the decrypted block, we need to give the original plain text block. So this cipher block is also producing by encrypt and XOR output of the previous cipher block. Here we need to give the input to the next encryption algorithm. After XOR operation, we will get the original of plaintext block. But in the cipher blocks is producing an encrypted of XOR output of the previous cipher block, and we need to present the plaintext block. Means we are getting the output of plaintext. That was we have discussed in this previous slide, electronic code book. Whatever we are giving in the encryption format, we will get the output of ciphertext. In the decryption process, we are going to get the output of the plaintext process. In the same cipher block chaining goes also, encryption process is same and decryption process is also same. But the difference is nothing but using an XOR operation. Before we need to encrypt it, we need to perform the XOR operation, and after the encrypting of XOR output, we need to previous cipher block and to present the plaintext block. So first see here the encryption process. In this encryption process, we are having the P1 of plaintext and P2 of plaintext and so on up to Pn processes of plaintext. So again we are using here of K of secret key, and we are going to use by the encryption process, and we are getting the ciphertext process, output of ciphertext. In this ciphertext, the output whatever we got here, that we need to connect with the XOR operation. We need to connect with this XOR operation, and we need to get the output of the next ciphertext, and so on up to nth plaintext of the output of ciphertext. So what we have discussed here, by using the secret key, we got the ciphertext. But this ciphertext we need to give an XOR operation of previous ciphertext. That was we have discussed here. Previous cipher block, we need to present the plaintext blocks. In the same of decryption process, whatever we have sended here plaintext to the ciphertext, we need to here send the ciphertext into the plaintext by using the secret key and also using the XOR operation. So here ciphertext of first process and ciphertext of second process and so on up to CN process, we are going to decrypt the secret key of message. So the ciphertext of 1 is going to be decrypted, and by using the XOR operation, we are getting the plaintext format. So plaintext format is nothing but after the decryption of process and after the using of XOR process, we will get the original plaintext block. So see here, input to the next encryption algorithm, after XOR operation, we will get the original plaintext block. That was we discussed in the first one. So ciphertext of second process is also maybe to run. By using of secret key again, it is going to be decrypt, and by using the XOR operation. So whatever here giving the XOR operation to the previous of the first ciphertext. Here the first ciphertext is going to be taken as an input, and we get an output of the plaintext too by using an XOR operation. Like that, we need to continue this process up to CN process, and we need to use an secret key of K, and we need to decrypt this process again. But previous of this slide to C2, we are going to be connect an XOR operation, and we will get an output of the plaintext PN. So that is the process of encryption and encryption process and decryption process. So in every process, every blocks chaining methods, we need to run the two process. One is encryption process and second one is decryption process. So next, third one is cipher feedback mode. So what the cipher feedback mode gives? So it gives as an feedback to the next block of encryption with some of the new specifications. What are those new specifications? We can see here. First, an initial vector 4 is used for the first encryption methods, and output bits are divided as a set of S and BS bits. So we have taken here cipher feedback mode as first of initial vector 4, first as encryption process, and output are divided into the set of two types of bits. One is S bits and BS bits. There are two types of bits, nothing but S bits and BS bits. So on the left hand side, we are going to use an S bits along with the plaintext bits to perform XOR operation. So for this also plaintext bits, we need to apply an XOR operation is applied on the left hand side. This is the most important one. Left hand side, S bits are going to be select along with the plain text bits. Means whatever we are going to select plain text bits as left side, we are going to select as S bits format. So for this S bits process, we need to apply the XOR operation. So the main result is whatever here we are getting, input to a shift register having the BS bits to 1HS and S bits to RHS, LHS and RHS to the process to be continued. Wherever we are giving the S bits and BS bits for the LHS and the RHS. For the RHS, it will be get an S bits, and for LHS, it will get an BS bits. So difference is S bits and BS bits. So for S bits, we are going to do an RHS process, and for BS bits, we are going to use an LHS bits. So this is the two important points we need to remember, S bits and BS bits. So see here. So whatever I am applying here, I am taking as an initial vector here process. So for this process, we are going to do as an secret key. For every process, we need to, whenever we are going to secure our information or we are passing any information, we need one particular key that is called as an secret key, that is represented with the K key. So this is consists of block cipher encryption. Wherever we are giving the block cipher encryption, we need to use the plain text process. Plain text process is divided again with the XOR operation is applied. Wherever we are selecting with the left side of the plain text process, we need to apply with the XOR operation. So again, we need to get the output of the ciphertext. So that was we have discussed in this slide. That is left hand side S bits are selected along with the plain text bits. That is XOR operation is applied. So for doing an initialization vector, we need to apply some of the key with K, and by using the block cipher encryption, we need to get an plain text. The plain text is applied to the XOR operation. That XOR operation is giving to output of the ciphertext. So like this, the ciphertext of the XOR operation, it moved to the second block, and the second block also contains of key K and the plain text. The plain text is again applied with the XOR operation. It gives the output of the ciphertext of 2. Like that, we need to do the end of the process. The same process is run to be the decryption also. For the decryption process, what we need to get in the decryption process? Ciphertext is going to be conducted with the XOR operation. This XOR operation, we are going to give an original plain text. So that is the process of ciphertext. By using the XOR operation, again we need to give the plain text process. That is the cipher feedback mode. The next fourth type is output feedback mode. In this output feedback mode, all bits of the block are sent instead of sending selected S bits. Means whatever here selected the S bits, we are send instead of sending all bits. Means instead of sending S bits, we are sending the all bits of the block for the output feedback mode. And this feedback mode, it consists of the block cipher holds towards bit transmission errors. So bit transmission errors, it also contains with the initialization vector. So towards it transmission errors, we also decreases the dependency or any other relationship of the cipher on the plain text. Means initialization vector is also representing of the key by using the block cipher encryption process. Encryption, why here we are discussing only for the encryption process. So while we are discussing for the decryption process, we need to here keep the block cipher decryption process. So converting of the plain text by using the XOR operation, we need the output of the ciphertext. Means we are selecting the, instead of S bits, we are selecting the all bits in the block. Means all of the blocks is going to be connect each other. The second process is going to be connected with the first process. This first process is going to be connected with the again block cipher encryption process by using the key K. Again, the plain text is going to be converted into the ciphertext by using an XOR operation. So already we have discussed in the previous slide of XOR operation, that is 0 0 1 0 0 1 1 1. While we are getting 0 0, we will get in 0 1 0 1 0 1 1 1 1 0. So while we are performing in the XOR operation, we need to represent as a symbol of this. So that is the main important point of representing the XOR operation. At the time only we can do the encryption process and the decryption process. So like that, with the previous slide of, again next to the process of plaintext and ciphertext, we are connecting with the previous block. The block is again converted into the key and it contains plaintext into the ciphertext by using the XOR operation. That is the output feedback mode. We need to remember only one thing, that is selected as bits. We are going to be select all bits of the block, means everything block is going to be connected in the each other. And fifth type is the counter mode. In this counter mode, it is a simple counter based block that is contains of a block cipher implementation. It is nothing but a one type of simple counter based block and it contains the implementation of the counter mode. So every time it can be counter initiated value is encrypted and given as an input to the XOR operation. While they are performing the input to the XOR operation, it gives an counter initiated value while they are encrypted and results in the ciphertext block. So automatically while we are taking as an input of plaintext, it automatically gets the output of the ciphertext. See here, counter 1, counter plus 1 and counter plus n minus 1 means counter 1, counter 2, counter 3, counter 4, counter 5 and so on up to counter n plus 1, counter n minus 1. So we are going to do as a process of from 1 to n minus 1 process. So like that we are going to be add some of the process, means here counter 1 is there. So I'm adding the next of the 1 plus 2. Like that we need to add up to the last process. So here the counter is going to be taken as an input of using K key that is encrypted with the plaintext of the process P1. So after getting the plaintext of the process P1, we are doing as an XOR operation. So it is already given here, the input to the XOR operation with the plaintext, it results to the ciphertext block. Means whenever we are using in the counter block, it is going to be encrypted with the plaintext of P1. Means we are going to implement as a number format. P1 is going to be implemented with the ciphertext of C1 by using the XOR operation, and also the counter plus 1 means this process is also now added in this process. Means counter plus 1 process is also added here. But the change is nothing because we are using the same key and we are using for the encryption process and we are using the XOR operation to get the ciphertext as output and input as the plaintext, means with the representation of P2. Like that, the counter plus 2. Counter plus 2 is nothing but we need to add the counter plus 1 of the previous slide. At last, we need to get the counter plus n minus 1 of the format. So counter n minus 1 is also we need to repeat as the same process of by using the key. We need to get the encryption process and we need to use the XOR operation of plaintext n up to the process to get the ciphertext of nth process. Means up to C1 to Cn process and P1 to Pn process. That is the counter mode. So in today's session, we have discussed a model for network security and that is a type of the example and block cipher modes of operation. So they are discussed with the 5 types of operation. So in the next session, we will discuss data encryption standard, that is nothing but DES, and so what is the strength of the DES and triple DES, means 3 times of the data encryption standard. We will see in the next session. Thank you.